what is a parametric function and how do we take its derivative? So a parametric function is usually a function that both take a common input, usually t for time. So let's say you have a function x equals to 2t and y equals to 5t squared. So using some basic algebra, we're able to find the relationship between x and y. We see that t is equal to x over 2, and then we can just plug this value into the t in the y. And then we now see that y is equal to 5 times x over 2 squared, which is equal to 5 over 4 x squared. So we were able to find a relationship between x and y, and this is called removing the parameter. So then how do we define the derivative of this parametric function right over here? So we can use something that's called taking the derivative of a function with respect to another. So just to quickly prove this generally, let's say I have a function u of t and another function v of t. So I can find du over dt, and I can also find dv over dt. And remember, our goal is to find du over dv. This is our goal. So you can probably see that if we divide du over dt by dv over dt, we get that, remember, dividing by a fraction is the same as multiplying by its reciprocal. So we get du over dt multiplied by dt over dv. Now the dt's can just cancel out, and we get du over dv. So we've shown that generally speaking, if we're given two functions, then this is how we can find the derivative du over dv. Now going back to our previous example, we want to find dy over dx. This is our goal. So as we've proved, we can just find dy over dt and then divide that by dx over dt, and we end up getting, I'm just going to do the dividing by a fraction is the same as multiplying by its reciprocal one more time to just demonstrate the idea of how we get dy dx. And we see that this results in dy dx. Okay, great. So what is dy dt? Well, dy dt would just be 10t, whereas dx dt, as you can see over here, is just 2. So if we divide 10t divided by 2, then we get dy dx is equal to 5t. So what just happened here was that we used taking the derivative of a function with respect to another to get that dy dx is equal to 5t. One application of taking the derivative of a function with respect to another is taking the second derivative of a parametric function. So recall how a second derivative, d squared y over dx squared, this just tells us how the first derivative changes. So in our case, we want to find how dy dx changes, but with respect to x. Now, to make this simpler, I'm just going to represent dy dx as y prime. So now we can use the principles of taking a derivative of a function with respect to another. we can find dy prime dt, right? And we can also find dx dt again. And guess what? If we combine, or if we use both of these equations, we can get dy prime over dt divided by dx dt is equal to dy prime over dx. Now, what does this expression tell us? Well, this is what we wanted to find. We wanted to find how the first derivative of our function over here changes with respect to x. We just wanted to find, so in other words, this is our second derivative. So this is equal to that. So in the previous example, d squared y over dx squared, or the second derivative, would have just been dy prime over dt. This of the previous equation is 5, whereas dx over dt, once again, is just 2. So we see that this is the second derivative of the example. So a lot of calculus teachers might not show these steps because they're very simple, but honestly I find that it's in these simple but detailed steps where confusion happens. So I hope this video was of value to you. Please consider supporting my channel, and thank you for your viewership.